Jupiter, a planet famous for its enormous storms, harmful radiation, and breathtaking beauty. It's a mighty giant, so massive that its size even impacts the sun itself. Jupiter is becoming one of the most explored objects in our solar system, with 7 flybys, 2 orbiters, 1 still active today, and 2 more missions planned. There's so much we still need to discover about the 5th planet from the sun. What gives it its distinct red color? What is it made of? What lies hidden beneath its thick clouds? And what do we truly understand about the Great Red Spot? Jupiter plays a crucial role in defending our solar system, and now is the time to uncover its mysteries. Hi, I'm McColgan, and welcome to Astrum. Join me today as we explore everything you need to know about Jupiter. The 5th planet from the sun, Jupiter sits on the outer edge of the asteroid belt between Mars and Saturn. It's about 778 million kilometers from the sun on average, or 5.2 astronomical units AU. And it takes 12 Earth years to complete one full orbit. Jupiter's axial tilt is just 3 degrees, which means it doesn't go through significant seasonal changes like Earth or Mars. Much like Saturn, its equator radius is larger than at the poles. Jupiter is the largest planet in our solar system. It's so huge that its mass is 1/1000th of the sun's mass. That might seem small, but when you realize the sun holds 99.86% of all the mass in our solar system, Jupiter makes up almost the rest. Its mass is 2.5 times that of all the other planets combined. This leads to an interesting phenomenon. The barycenter, or the center of mass, between Jupiter and the sun is actually above the surface of the sun, about 1.068 solar radii from the sun center. Let's talk about barycenters. When we think about one object orbiting another, we usually don't consider that the smaller object has a gravitational influence on the larger one. This effect is usually so tiny, like the International Space Station orbiting Earth, that we don't notice it. But with Jupiter, the effect is massive. Both Jupiter and the sun orbit around a point in space, the barycenter, which is above the sun's surface. To better understand this, imagine balancing 2 objects of different weights on a stick. The stick balances at the center of mass, which will be closer to the heavier object. If Jupiter is the heavy object, it pulls the barycenter away from the sun center. Though Jupiter is the most massive planet, it's not the densest. Its size makes it the largest. If Neptune were the same size as Jupiter, it would be the heaviest. If Jupiter were the same size as Earth, Earth would be more than 4 times as heavy. Jupiter's diameter is 11 times larger than Earth's, and its mass is 318 times greater than Earth's. Jupiter's gravity is more than twice as strong as Earth's, at 2.528 g on its surface. This immense gravity influences all the other planets. It's powerful enough to break apart asteroids and capture at least 67 moons. Some scientists believe Jupiter has destroyed many celestial bodies in the past, even stopping the formation of other planets. For example, it's thought that Jupiter may have affected the asteroid 4 Vesta. Jupiter's gravity is so powerful that it even affects Mercury's orbit. In a few billion years, Mercury might crash into the sun or be thrown out of the solar system. Right now, though, Jupiter's gravity is actually protecting the inner planets. It acts as a cosmic vacuum cleaner, pulling in harmful objects like long-period comets and sending them out of the solar system. Jupiter, the 5th planet from the sun, is 5 times farther away from the sun than Earth. But despite that, it can be the 3rd brightest object in the night sky, after the moon and Venus. Its brightness is so strong that it can cast shadows. With a maximum apparent magnitude of -2.94, it's easy to spot with even a basic camera. Due to its brightness, Jupiter is an excellent target for amateur astronomers. Thanks to advances in telescope technology, you can now see incredible details from your own backyard. The beautiful bands in Jupiter's clouds are created by compounds deep inside the planet that heat up and rise. These compounds, called chromophores, react with ultraviolet light from the sun, creating these amazing colors. The bands may change over time, but they generally stay in the same positions. The Great Red Spot, a massive storm on Jupiter, is a result of these turbulent cloud patterns. This storm is so large that Earth could fit inside it. It's been around since the 17th century, and although it's shrinking, it remains a permanent feature of the planet. The reddish color of the Great Red Spot is still a mystery. It may be caused by chemical compounds breaking down due to sunlight, similar to how other parts of Jupiter's clouds are colored. This storm is much higher in Jupiter's atmosphere, where it interacts more with sunlight, which might explain why it's so colorful. Jupiter has more than just one storm. Another storm, called Red Spot Jr., appeared between 1998 and 2000 when three smaller storms merged. This new storm has survived so far and could last a few more centuries, depending on how it interacts with the Great Red Spot. So what is Jupiter made of? Like Saturn, Jupiter has layers of hydrogen, gas, liquid, and metallic beneath its clouds. The deeper you go, the more pressure there is, and hydrogen becomes metallic. Beneath that, there's likely an icy or rocky core, though we're not completely sure because we can't simulate the extreme pressure of Jupiter on Earth. About 90% of Jupiter is hydrogen, 10% is helium, and the rest consists of trace elements like methane and ammonia. Jupiter also spins very quickly, completing a full rotation in just 10 hours. However, because it's not solid, it doesn't rotate at the same speed everywhere. The poles rotate 5 minutes slower than the equator. As a child, I often wondered why Jupiter wasn't a star. After all, it's so huge, and it's mostly made of hydrogen. But stars work differently. They generate energy through nuclear fusion, which happens only under extreme pressure in a star's core. Jupiter would need to be about 75 times more massive to become a star, although its size is almost equal to that of the smallest red dwarf stars. Jupiter does have rings, though they're much smaller than Saturn's. There are 4 rings, with the main one being thin but bright. The other rings are wide but faint. The main ring is about 6,500 kilometers wide, with a feature called the Métis Notch. Jupiter also has the strongest magnetosphere of any planet in the solar system. It's 14 times stronger than Earth's, and only the sun's sunspots are more powerful. This intense magnetosphere creates stunning auroras at Jupiter's poles and protects its moons from solar wind. However, Jupiter's radiation belts are hazardous. The closest large moon, Io, passes right through this dangerous zone and receives 3,600 rem per day on its surface, enough radiation to kill a human in just a few hours. Jupiter has 67 known moons, with the 4 largest, Io, Europa, Ganymede, and Callisto ***, being among the biggest in the solar system. Ganymede is the largest moon of all, even larger than Mercury. These moons are all fascinating and deserve further exploration, which is why I made a separate video about them. Lastly, take a look at Jupiter through infrared. This image demonstrates the massive size and power of the planet.